Right, so this is looking at the other way of doing it. So this is quite often the case where you're given a curve with a function. So we're told that this curve represents this function. So it's very similar to the curve I had on before, except now we want to find the actual values at these points. We want to know what's going on at each of those points. So there's 3 points. They have two parts to the coordinate each. So for each of them, we want the t part and the v part. So A is going to equal something, something, B and C. Okay, well, this is the t part, and that's the v part. Okay, because you always do the x, or the horizontal axis first, and then the vertical axis. So t values, v values for each of A, B, and C. That's what we're trying to find out. Now, some of these are really easy. So there's 6 numbers we're trying to find. Some of those 6 numbers are ridiculously easy, and some of them are a little more complicated. So let's pick off the low-hanging fruit. Which ones are really easy? Which ones can I just put in there without having to think about it? What do you know about C? The up or the along? How far up is it? Okay, so C is 340 up. Okay, it's at the top, and the thing only goes, the amplitude is 340. So we know that. Okay, so that's one of the easy ones, really easy. Harrison. So say it again slightly slower. I think you're right. AV is 0. Sure you got me around the right way? You have, haven't you? So AT is 0. Yep. So when you're at A, you've got 0 T. And when you're at B, you've got 0 V. That's what you want to do. That's 3 out of the 6. So that's half of it done with just knowing what a graph, where things are on an axis of a graph and what the thing at the top is. Yep. So those 3 are pretty straightforward. Okay, that's what I mean by low-hanging fruit. Okay, what's the next reasonably easy one? There's one more that you can do fairly easily. This one here. See this time along here? Yep, so how are you going to do that? Yep, okay, so that's just the phase time, isn't it? Yep, so okay, so whatever is going on, it's a time, because it's on a time axis, and it's how much it's out of phase by, so that's just the phase time. Okay. Travis. Yeah, and that's why I've sort of put the negatives in brackets. It's a convention thing. So the negative is because it's gone negative. So you normally just talk about a phase time of 150th of a second. And your normal, especially in the electrical stuff, you talk about leading and lagging. So whether it leads the phase or it lags the phase. You'd be fine at this level. Yeah. This one here is clearly positive, because now this is the 0 point, so B is on the positive side of the point. So the answer here has to be 1/150th. 1 over 150, which you could work out as a decimal if you wanted to, but that'll be fine as well. Okay? So that's just the phase time. Whatever the phase time is, that's all that B is. Wasn't the one I was expecting, Darren. That wasn't the one I thought was the next easiest one, but there you go. That's well done. That's a good way of doing that. Okay, there's only 2 boxes left to fill in. Which one can you do reasonably easily? Or maybe you're going to get them all different. Yeah, I think AV is reasonably easy. No, it's not. It's clearly not 0. It's below 0. It's negative something. So how are we going to work out where that point is? What do you already know about that point? It's in the negatives, but about the actual point. You know that t is 0. Have you got a formula for this curve anywhere? what happens if you make t equals 0 in that formula? So when t equals 0, v equals 340 times sine of 50 pi times 0 minus pi over 3. I just slopped in the t equals 0. Yep. And said, that's it. And this stuff is all calculator friendly. Everything in that line, you've got a button that looks like that on your calculator. So just type all that muck into your calculator and come up with something. What's sine pi over 3? 60 degrees, root 3 over 2. What you got? No, maybe I've got, what do you got? Okay, -6. Why do you think it's wrong? It looks far too shallow. I agree. So what's your problem? Hang on, Kieran's thinking the brainstorm's just hit. What is it? What's the problem, Kieran? Oh, no, what's this thing? What's this thing? Yeah, I think radians would be a smart move. -294.44. Units? You got the same, Ricky? Yep. Units? Volts, thank you. It's cool. Let's do 170 times the square root of 3 and see what you come up with. Some number? Yeah. Yeah. How do I know that? It's exciting. Yeah, no, how do I know that? Okay. This is how education has changed. When I was in the 4th form, so we're going back 30-something years, I had to learn by heart sine, cosine, tan, 0 degrees, 30 degrees, which is pi over 6, 45 degrees, which is pi over 4, 60 degrees, which is pi over 3, and 90 degrees, which is pi over 2. Yep. Sine starts at 0 and goes to 1. Cos starts at 1 and goes to 0. This is a half. This is 1 over root 2. This is root 3 over 2. Then it goes the other way, root 3 over 2, 1 over root 2 a half. Tan is sine divided by cosine, so that's that. That one's undefined. That one divided by that one is 1 over root 3. That's the same. And that's root 3. Yep. So when I'm looking for the sine of, that bit's just 0. So the sine of pi over 3 is root 3 over 2. So it's just going to be 340 times root 3 over 2. Those guys cancel out to leave 170. Yep. That's how you do it. So just for those numbers, for those 30s, 45s, and 60s, I know the exact values for them, not even the decimals, but the exact values. Yeah. Yeah. I'll show you a clip from Big Bang Theory later, where they're trying to take the box of stuff up the stairs. Has anybody seen that? It ends up with the great line where Sheldon says, "Gravity, thou art a heartless bitch." Yep. So they're trying to shift the box up the stairs, and they try to lift it up, and then they put it on the slope, and it goes up the slope easier. And Leonard says something about, I do a calculation, we call it 30 degrees, sine of 30 about a half. And Sheldon goes, sine of 30 exactly a half. It's that point there. Yep. So. It's pretty funny. I do watch it because it's funny. I really enjoy it, and it is really good to watch. But a lot of the maths and the science, it's got that extra level to it as well. If you understand the maths and the science, there's a lot of stuff there which is It's pretty funny on another level as well. I bet there's a level below what I understand as well in some of the physics stuff. I get some of it, but yep. Okay, so calculator is fine. Once you get to that lot, everything there you can type into your calculator. So just go for it on the calculator, and you get an answer. Yep. So that one's nice and easy. Just crunch it into the calculator. So negative 294.4. Brilliant. I'll rub out all this rubbish. But thank you for asking that question, Jaden. It's always nice to be able to show off a little bit. Yeah. Get rid of that. Okay, so we're only left with one box. How are we going to figure out how far across we have to get to C? Quarter of a period plus B. You're onto it. Yep, that's certainly one way of doing it, is to say that this whole thing is one period, and we're going from here to here is a quarter of a period. Yep, so that's 1/4 of a period, and we worked out the period was 0.04, which is 0.01. Yep, and we could just add that on to the 1 over 150th. Yep, so it's going to be 0.01 plus 1 over 150, which someone's going to crunch out as a decimal for me. What's your okay? 0.016. That's cool. Okay, so that's certainly one way of doing it. We'll call that the Darren method. I think it's pretty good. It's nice and insightful. You can just see what's going on. I've gone along a quarter of a period onto B. That's definitely one way of doing it. The other way of doing it, if you're a little less confident, is you could say when V equals 340, and then rearrange the equation. So when V equals 340, we get 340 equals 340 sine 50 pi t minus pi over 3. And just rearrange that equation to get t out of it. And you should come up with exactly the same answer.